Hello. Yeah, I have it set up, kind of. You can look at 24. I guess I can start there. I will do one similar to it, but not the exact problem. Okay. Couple minutes here and we'll start. Okay. If you can get it done by Monday, that'd be great. Tests. I will probably check them Monday, and then I'll give them back to you for you to fix. Hopefully, either Monday or Tuesday. But yeah. If you have questions about the test, you probably at least should have taken a look at it yet. I know Eli had a question on 24, which is probably one of the more difficult ones just because of the way it's worded. But I will give you an example of 24 here first. So 24 is the one about the ant colony. This is what 24 reads on your test. In one ant colony, exactly 0.05%. Keep in mind this is a percent of the ants are missing one antenna. Is there a minimum number of ants that must be in the colony? I mean, yeah. If there is, I mean, clearly there has to be a minimum because there's a percent that have an antenna. I mean, it wants to know what that minimum is, though. And we're going to solve something similar. We're going to change the problem so you can do this on your own, but it follows the same method. So let's change this percentage, and we'll keep it as a decimal. We'll put 0.04. Yeah, we'll just make it 0.04 of a percent. That way you're going to follow the same procedure. You're just going to do it with 0.05 instead. And this goes to the definition of percent. So remember, a percent is a part of 100. So 0.04% is equal to 0.04 out of 100. Right? So if there were 100 ants, 0.04 would have one antenna. But that doesn't make sense because you can't have 0.04 of an ant. So what we're going to do is we're going to actually find a version of this fraction. We want the simplest version of this fraction with a whole number numerator. So what we're going to do first is we're just going to multiply each by 100 to get that decimal point out. So I'm going to multiply this by 100. I'm going to multiply this by 100. This is still the same percentage. So it's just 4 over, instead of 100 here, you're going to have 100 times 100, which is 10,000. So 4 out of 10,000 don't have, are missing one antenna. That's what that's saying. However, that's not the minimum. If there were 1,000 ants, only 4 of them would be missing an antenna. Well, what if only one was missing an antenna? Right? So let's see if we can divide this by 4 and divide this by 4 as well. Again, we're keeping the same percentage. We're just finding an equivalent fraction of it. And this is going to equal 1 over, and then 10,000 divided by 4 is probably what, like 200 or something. 10,000, probably 2,000. 10,000 divided by 4 gives us 2,500. So 250. So in our ant colony, if we have 200 or 2,500 ants and 0.04% have one antenna, antenna singular, have one antenna, then only one ant has one antenna. And that's the smallest number there could be then. Because if this number was any smaller, this number would be a fraction, and you can't have a fraction of an ant. So you're really just changing this to a fraction, then finding its simplest form without it being a decimal in the numerator, because that's frowned upon. And then you're looking at your denominator. So here it would be this number here. I can do another example. What if instead of having 0.05, this was 0.25%? In that case, again, you just make that percent a fraction, because that's the definition of a percent, 0.25 over 100. This means out of 100 ants, 0.25 of an ant has one antenna, but you can't have 0.25 of an ant. So we're going to move the decimal point out by multiplying by 100, because we're moving it 2 places. If we only moved it 1 place, it would be multiplied by 10. We just want to get a whole number on top. So get this a whole number. Get a whole number here. In that case, you're going to get 25 out of, and then 100 times 100 is still that 10,000. And then when you divide that out, well, when you simplify that, you can divide each of these probably by 25. Well, you can, because 25 is a common factor. So 25 divided by 25 gives you 1. So if one ant had the missing antenna, then one ant represents 0.25%. How many ants were there? And that's just 10,000 divided by 25, which gives you 400. So in this case, your answer would be 400 ants. We'll have 1 with a percentage. Yeah, I know it's worded weird, but it's asking you to explain, and then explain would be the part that I'm really looking at. Like, what does this fraction actually mean? And this means that if for every 400 ants, one of them is missing an antenna. For every 100 ants, 0.25 is missing an antenna. That's really what I'm looking for, is that explanation. And that's just kind of understanding what the ratio means and what the fraction, what do these numbers actually mean in this context. I know it's a strangely worded question because I stole it from the book, but I kind of liked it. I'm not sure how useful ants and antennas are to you, but it is what it is. Are there any other questions about the test? Any other questions that were confusing to you, you didn't quite understand? Again, I can probably do something that's similar, but I'm not going to do the exact problem. I don't even have the test open. I don't know which questions are which anymore. And if that changes, you can always email me over the weekend. And I'll tell you Monday, or I'll make you a video or something, depending on what my schedule's like. I've been pretty busy lately. So if there's no more questions, let's move on to new stuff. And I will ask you to take notes on this. I did not make a PowerPoint for this yet. I mean, I have one, but it's going to be a lot of fraction work. Okay, I'll do number 22 once I find it. It's going to be a lot of fraction work for us, and writing, like typing in there, like the Google Slides doesn't let me do fractions very well. So I kind of didn't type it up, but I gotta find the test here. I don't even have it open. Classwork. Let's see. I'm looking for 22 and 2. Test. 26 and 25 as well. Well, maybe we'll just spend today looking at test questions. Let's see. 2. 272%. And it wants it as a fraction. Fraction or mixed number. Alright, this is 2 for Anna. I'm just going in order. Anna, I'm not going to solve this problem for you. You're going to do it on your own. I will just change it and show you how to solve one that's similar. And let's say it's 583% instead. And again, to make that a fraction, you're going to use your definition of what a percent is, and it's just parts of 100. So this is equal to 583 out of 100. And then you're going to simplify this fraction as a mixed number. You're going to ask yourself, how many times does 100 go into 583? Well, it goes 5 times. And 83 left over, so that's your numerator over 100. And then you're going to figure out if you can reduce 83 over 100, which I'm not so sure you can. But yeah. So it is the same thing you were doing for 1, 2, 3, and 4. It's all the same process. Don't let the over 100 thing fool you. I mean, you could have also thought of this as, I mean, this is going to be over 100, right? So that's going to be 272 over 100. Just reduce it. Okay, next up was 22. 22 for, what is this, Porter wanted this? Porter, did you still need 22? $22 is 85% of what number is 340. Again, percent over 100 equals is over of. There's a percent. There's an is. You can solve it from there. Right? Cross multiply and then divide out to get your x. And that's going to be done the same way for all 3 of those problems. So all 3 of them are done like that. Let's see, 26. These are percent change. 25 and 26. Okay, they're percent change. So 25 and 26 together. This is Catherine. Yeah, 25 and 26 together, it is percent change. So you're following your new number minus your old number divided by your old number times 100. So if you were going from, what is it, 30 to 37, we're not going to do 30 to 37, we'll do, I don't know, 20 to 27. Right? It does not matter if this is an increase or decrease. I just told you that because it just kind of made more sense to write it that way at the time. But I am going from 20 to 27, so my new number is 27, my old number is 20, and I divide by 20, and I multiply by 100. 27 minus 20 gives me 7 over 20. Divide that out. I don't know what it is. 7 divided by 20 gives you 0.35, then you're going to multiply that by 100. This is no longer equal if I'm multiplying it by 100, and that's going to be 35%. So again, you're just going to follow this template here. And that's going to be true for 27 as well. Any other reminders for the test? Anyone else stuck on something? Are we good to start dimensional analysis? All right. If you have questions about the test, you're emailing now. All right, dimensional analysis. I don't need that anymore. I don't need that anymore. Okay, our next chapter, which is chapter 12, just so you know. Chapter 12. This is a whole chapter based on one topic in my eyes, and that's conversions. Chapter 12, so like 12-1 is a section, 12-2 is a section, and 12-3 is a section. That's all it is. It's a 3-section chapter, and it's all about converting units. 12-1 is using the U.S. imperial system. Imperial system, which we also call our customary system. Is that what they called it? Yeah, these are also customary units. 12-2 is your metric system or your SI system. And it's about converting within there. We actually did that at the beginning of the year with a strange looking staircase, if you recall. And section 3 is about converting between US and metric, which all of these are the same thing. And it is one thing you need to learn. However, that one thing seems fairly complicated at first. So we are going to spend some time looking at it. But once you get the hang of it, it's actually pretty simple. If I can erase anything. All right. So you're going to get questions that are going to be like this. How many pounds is 20 ounces? And you'll note ounces and pounds are different units. And you need to be able to convert ounces to pounds, pounds to ounces, things like that. And the way we're going to solve all of these, so anytime you have a problem where it's converting units, you're going to use what's called dimensional analysis. Dimensional analysis is just, yeah, take notes on this a bit today. I'm going to try my best to explain what this is, but I kind of hope that I'll take you all the way to 2 o'clock. And we will be spending more time on Monday and Tuesday and probably Wednesday as well, if not all of next week on this. But yeah, take notes. So dimensional analysis. Dimensions are like your units. So think about your dimensions, right? You have length, width, and height. Those are all types of dimensions. We can measure those. We have measurements of length, right? So you should know some measurements of length. In any system, these are like meters, right? Inches, centimeters, yards, furlongs, if you know what a furlong is, miles, nautical miles, because they are different, right? Miles are based off of straight lines. These are based off of arches, because when you're on the ocean, the world is curved, so you travel in nautical miles. This distance to this distance is different than this distance to this distance. So just some interesting things. But you know a lot of measurements of length. You've been using them. You also have measurements of capacity, which is volume. And you've used these as well. These are going to be like your fluid ounces. These are going to be your liters, your milliliters, things like that. You know those. You know what some of those are. U.S. customary ones, I guess you got cups, pints, gallons as well. Right? You also have units of time, which you should be familiar with, which are like seconds, minutes, hours, days, weeks, months, years. yada, yada, yada. At the beginning of the year in science, we took down all of these in your science notebook, if you recall. Right? And you have other types of units out there. What you need to know about these units in order to do dimensional analysis is the stuff that's not given to you. And this is stuff that you either have memorized or you look up. And they are going to be conversion ratios. So you need to know conversion ratios to do these. And these are going to be standard ratios that everybody has agreed upon to use. And if you don't know them off the top of your head, it's a reference. You go and look it up. Some of them you should know. For example, you should know that there are 12 inches in 1 foot. Right? This here is a ratio. It is 12 to 1. Right? 12 to 1. Right? Inches to feet. You should know that. You should probably also know there are 3 feet in 1 yard. There are 36 inches in 1 yard. There are 1,582 inches in feet. 5,280, not 82, 80 feet in 1 mile. There are 1,760 yards in 1 mile. There are 63,360 inches in 1 mile. You might know some of those, you might not know. I mean, nobody knows this. But, I mean, you might know some of these, you might not know. Bottom line is, if you don't know it, it is referenced and you look it up. And honestly, I will probably link one of these later in the next week, but I just like Googled Pinterest here and it gives you them right here. Right? I mean, this is just a document from Pinterest. It tells me there are 8 ounces in 1 cup, 2 cups equals 1 pint, 16 ounces equals 1 pint, 4 cups equals 1 cup. I mean, there's charts like this everywhere. They're just conversion ratios. People need them so they can convert from one unit to the next, because you need to have your units cooperate. They need to be measuring like things all the time, right? You can't add inches to miles. You need to add miles to miles. So if you ever come across something where you need to change inches into miles, you convert it. And that's what this whole chapter is about. It's about converting. So when it comes to dimensional analysis, right, let's look back at our example here. How many pounds are in 20 ounces? So what I'm going to do is I'm going to go and look up how many pounds are in an ounce. I need that relationship. And if you don't know that off the top of your head, you look it up. And there are 16 pounds in 1 ounce, I believe. Or 16 ounces in 1 pound, sorry. There are 16 ounces in 1 pound. So this is information I looked up because I didn't know or I had it memorized. 16 ounces equals 1 pound. I need this information in order to solve this problem. I can't do it without this information. I need to know the common ratio between ounces and pounds, and here it is. It's right here. It's 16 ounces equals 1 pound. So again, you look these up if you don't know them. Some of them, hopefully, you have memorized. Like you should. I'd be very surprised if you didn't know there was 12 inches in a foot. 16 ounces in a pound, maybe. You might know, maybe you might not know. I mean, I don't know how much you use ounces and pounds in your everyday life. I know I stress the metric system a lot because it's just easier. But there it is. So how do you do dimensional analysis? Dimensional analysis is always going to be set up the same way. So here's dimensional analysis. It's always going to be a whole bunch of fractions multiplied by each other. And you don't know how many fractions you actually need, but it's always going to be just multiplying fractions. And that's the beauty of this, because it will always be multiplying fractions. That's the only math that's really involved, is multiplying fractions. If you can multiply, you can do dimensional analysis. The problem people have is setting it up. Like, how many of these fractions do I need, and what do these fractions need to say? Well, you follow your units to find that out. So you need to follow the units. Do not worry about the numbers, worry about the units. This is all about units. So follow your labels. The first fraction is always going to be your given. This is what information is given. Looking at the problem, it asks how many pounds is 20 ounces. This is what I know. I know 20 ounces. So that's the fraction that goes here. And how do you write 20 ounces as a fraction? Well, 20 ounces is on top, and I'm going to use OZ. And there is no denominator for it, so it's assumed to be 1, because remember 20 divided by 1 equals 20. This does not have units in this case. Sometimes you get numbers that have double units, especially if you were paying attention with Newton's laws and stuff. I mean, I think acceleration or something has multiple units to it. It's not a base unit, it's meters per second per second. Here you have even 2 denominators, or you're right, is meters per second squared. Here you have meters as a numerator and seconds as a denominator. So you would have a unit for your numerator and you'd have a unit for your denominator. It comes right out of it, so follow those units. We're not going to get into acceleration. But just so you know, we will get into things that have units on both the top and the bottom. And those are going to be just rates. In fact, you've done some of this with unit rate to begin with too. So here we know we have ounces on top and nothing on the bottom. And again, we're following the units. My goal over here is to have pounds on top, because that's what it's asking for. How many pounds? So I'm going to convert ounces to pounds. In order to do that, I need ounces to go away, and I need pounds to come in. So I need a ratio that relates ounces to pounds, and I have one right here. This is my conversion ratio. I'm going to use this ratio right here. And again, if you don't know those ratios, you kind of look them up. So over here, I need ounces to cancel out because I need it to go away. And when it comes to division, because you can see this will be a numerator, this will be a denominator. When it comes to division, ounces has to cancel, so ounces has to go on the bottom. That way when I divide, ounces divided by ounces cancels out and goes away. If I'm following my units, it makes everything else fall in place. I know ounces is on top here, so ounces has to be on bottom over here to cancel out. If ounces are on bottom here, my relation is to pounds. Pounds has to be on top. Once I get my units in, my numbers plug right in. 16 clearly goes with ounces, so I'm going to type 16 there, and 1 clearly goes with pounds. I'm going to put 1 there. And now I know ounces are going to cancel, and it's going to leave me with just pounds. Pounds didn't go anywhere. Well, that's what I want, so I actually don't need more ratios for this. Some of them you will need a lot more ratios. In fact, I'll give you an example. We'll do a nice one today. Right? I don't need any of that. In fact, we'll just move this over. Right? I don't need any of that. Now I just solve my problem, and it's just multiplying fractions. So multiply your numerators. 20 times 1 is 20. 1 times 16 is 16. And then divide or reduce, however you feel comfortable doing things, and get that as your reduced number. So if you want to put it as a fraction, which you are more than welcome to leave it as a fraction, right? That reduces by 4, so I can divide each by 4. So 16 divide by 4 gives me 5/4, which is equal to 1 1/4 pounds. You could leave it like that, or you can just do your division here and do what is it? 20 would go in the box, right? 16 goes into 20. 1 time 16, you're left with 4 decimal point 0, bring it down, and you're going to get 21.25 eventually, once you do all your division here. Goes twice, which is what, 32, that brings down, gives you 8, bring down the 0, 16 goes into 8 5 times, so 1.5 pounds. Don't lose your units. So either one is acceptable answer to me, but you're just following units through it. So I'm going to do one more example today, and then we're going to call it a day. And it's going to be a little bit more complicated, so we can just get used to doing things. And I want to know probably something that nobody really knows, but I want to know how many seconds are in 3 years. So let's find that out. We'll use dimensional analysis to figure that out. We're converting 3 years to seconds. So we're going to string together a whole bunch of fractions. That's all we're doing, stringing together a whole bunch of fractions using conversion ratios. And hopefully we have most of these conversion ratios memorized for time. I don't know if I need more than this or not. It's just a starting point. Again, this one here is going to be my given information, which is 3 years. So that's 3 years on top over 1. And there is no denominator to this unit, so it's just over 1. I know this has to equal seconds, so I want everything to cancel except for seconds on top. So I now need to take years to seconds. The big question here is, do you know how many seconds would be in a year? And the answer is probably no. You probably don't know that information. You might have to look that up, but we can take it step by step because we do have some information that we need to know, that we know. We know that instead of going straight to seconds, I can take multiple steps here. We know some kind of measurement of years. In fact, we know how many days are in a year, correct? Right, so I'm going to take this to days first. So I'm going to compare years to days first. And there should, in 1 year, there should be 365 respectively days. We're not going to take it to the decimal here. But in 1 year, there's 365 days. If I stopped here, my years would cancel. Note how I have years on the top, years on the bottom, they cancel out. Years divided by years is 1, they go away. And my answer would be in days, because that's the unit that's left. So this would tell me how many days are in 3 years. Well, I don't want days, I want seconds. Then you go and ask yourself, well, do I know a relationship with days? Because I need to get rid of days now. So in this fraction, days goes on the bottom. Do I have a relationship with days and seconds? You probably don't know off the top of your head how many seconds are in a day. However, you do know how many hours are in a day, hopefully. Right? And in 1 day, there are 24 hours. Note how 24 goes with the hours, 1 goes with the days. Here, days are going to cancel now. And if I solved this out, I would get hours as my answer. However, I don't want hours, I want seconds. And then we got to get rid of hours next. So this next fraction is going to relate something with hours. So hours cancels. Note how hours is on top here. Hours will be on the bottom here. So how many hours or how many seconds are in an hour? Again, you might know that. That's not too difficult to sit there and reason through. But instead of doing that math in your head, we might as well just plug it into our dimensional analysis and do it here. So we're going to say 1 hour is equal to 60 minutes. Right? So hours will cancel now, and I'm left with minutes. If I stopped here, I would get how many minutes are in 3 years. I don't want that, so I'm going to keep going. And I know that finally the relationship between minutes and seconds. And I know there are 60 seconds in 1 minute. So here, you'll note that years canceled, days canceled, hours canceled, minutes canceled, and you're left with seconds. Again, follow the units. It will tell you exactly how to set it up. Once it's set up, it's just multiplying fractions. Multiply your numerators, multiply your denominators, and divide. So here, we're going to be doing 3 times 365 times 24 times 60 times 60. And that's going to give us our numerator. and then 1 times 1 times 1 times 1 times 1 will give us a denominator of 1. So I'm going to go ahead and use my calculator to solve that out. You're more than welcome to. These can tend to get pretty big. 65 times 24 times 60 times 60. And that gives me 94608,000 seconds in 3 years. So our answer here is just that many seconds. I kind of ran out of room with the unit there. But again, dimensional analysis is going to solve all conversions, even if you wanted to go between US and metric. For metric, you have the staircase too that I showed you at the beginning of the year. But dimensional analysis is what I'd like you to get good at, especially when it comes to upper level sciences, because this is the way things are going to be done. Because these numbers can get very ugly in sciences and stuff. And this will be a systematic way to always convert whatever you need to convert. So with that, I'm going to do some more with you and give you your assignments on Monday for the start of conversion, so you'll have some practice with it. We're going to start off easy and build up to it, to slightly more complex versions of this, but it's all going to be the same thing. You're going to be multiplying by a series of conversion ratios and then reduce your ending fraction. That's all dimensional analysis is. Again, I can't stress following the units enough. Do not lose units in this. Units are part of your answer here. Just take your time, set things up, give yourself room to work, and you should be all right. But we will spend next week doing dimensional analysis. But this process will answer any question in the next chapter that you're given. And we'll even do some really strange ones too, because I got a whole bunch of dimensional analysis problems set up for us. So I will talk with you later this week. Again, be working on your test if you didn't finish it. I'd like to start grading them Monday. If you have questions about things, send me an email. Other than that, I'm going to end it there. I'm going to wish you a happy weekend. Keep in mind, get your science in. Your next chapter in science is going to be kind of an abridged chapter now, because our last day of school is 2 weeks before I wanted it to be. So keep that in mind. I haven't quite decided how I want to do that yet, but keep working on this current chapter. I know a lot of you still need more time for it. Please take the time and go over the material. Make sure you ask me any questions if you have it, if you're not understanding something. And I will talk with you either Monday, or if you have questions, send me an email this weekend. So I am going to end it, and I'll talk to you later. Bye.